Okay, this is your determination of iron content via UV-Vis spectroscopy. To save on time, the standard samples have been made with the exception of the first one, which we will use as our example to go through with how to make these. And the stock solution of your unknown as well as the 3 unknown samples have already been prepped also. But we will go through how we made those. Okay. So my accomplice in this is Bobby Worley. So just if you hear him or you see him.
I'm going to pause it real quick.
All right. The first standard sample requires 1 milliliter of our stock. Our stock was made by a former classmate. You can see how to make that. The first thing we're going to do is rinse our volumetric pipette as per analytical techniques. Okay. Then we are going to do this correctly and take pipette bulb off before you do that. As you can see, we have 1 milliliter in there with the bottom of the meniscus just sitting on the line. We're going to put that into our volumetric flask. Now, this volumetric flask already contains our hydroxylamine, our orthophenanthroline, and the sodium acetate. And remember, you don't blow out. This is to deliver. Now we need to fill this with DI water. You're right, that bottle may have a leak. Get it eye level. And make sure the bottom of the meniscus sits on the line. So all of our samples have been prepared like so. Invert, shake at least 3 times to make sure it's homogeneous. And this is what your standard series should look like, from least concentrated to most concentrated, and our blank. Our blank was made up with distilled water, the same amount of orthophenanthroline, hydroxylamine, and sodium acetate. And you should have that as to why we did that in your lab report for your discussion. Now, for our discussion conclusions, since you're not actually performing the lab and doing the techniques to get the data, you will get the data still, but I want your discussion and conclusions to focus, the first part of your discussion conclusion needs to focus on the method and the technique and why we do what. So it should explain, why do we have to make our blank with everything in it that we put in our samples as the solution? Why do we need a standard curve? And then we have 3 unknowns. Why would we need 3 unknown solutions made in the exact same way? So you need to include that, explain that for your discussion conclusions, because now we're moving more conceptual rather than you being hands-on here for the technique and the method. Okay. Our samples had to set for 10 minutes. The timer just went off for our 10 minutes for our unknowns. This will still need to set for 10 minutes, but this, by the time we get to our UV-Vis and have it all set up, should be done. So we're going to set another timer and we'll see you back at the UV-Vis. Okay, we are back at the UV-Vis. Just so you can see it maybe a little clearer on camera, I've marked our V with red so you can tell where we're going to line it up. We are going to be lining it up with the, let's do it this way, with the V to the right every time. You need to be able to explain to me why you want to line your cuvette up the same way each time, because that's part of the technique. Okay. The first thing we need to do is blank our instrument. So we have the blank that we made that has all of our stuff that's in the, sorry, I hit the tripod, that's in the solution. We're going to put a little in, rinse it around, dump it out into our waste. We're going to fill it to where it's the level of our liquid is in the pathway of our instrument. Otherwise, what's the use? Right? This is this way because if you can see this cuvette, this is the path length of 1 centimeter. If you do it this way, you won't get 1 centimeter. So that's why this V needs to go with the flow of the light that's hitting. We're going to put that in. We're going to hit our yellow rectangle for a blank. We're doing this from 400 to 600 nanometers. And it is now blanked. We're going to remove, dump, take our least concentrated. Has it been 10 minutes?
For
this one?
Yeah.
It has been.
No.
It's been close. Should we come back to? We're going to come back to that one just to make sure. We're going to start off with. We're going to start off with this one. We'll just rinse our cuvette really well. Rinse with the first. Fill. Pop this in. And read. We have a lambda max of 510 nanometers. This has an absorbance of 0.104. Could you write this down?
Yeah.
0.104. That's fine. This is for the second sample in the standard. We'll empty that.
Absorbance for what?
0.104. We're going to rinse.
Lambda max is 510.
Yep.
5 mils.
Yeah, that was the 5 mil. We're going to pop this in. Make sure it's lined up. Read this one. This is our 10 mil. Record this at 510 at 0.210. Ooh. Cup running over on that one. Ooh. Sure, I'll wipe off all that excess I got on there. And this one. This is 25 milliliter. Clean up my mess. Always make sure you clean up your mess. Go to 510. This is 0.521.
What are the units on that?
OD. Remember, there are really no units for UVVis. They are OD units, which is arbitrary units made for the intensity. But Beer's law states you have to maintain an absorbance of less than what? Which you should have in your report. This is 50. And why do we need to maintain OD units of that number, that little magic number that you need to discuss for Beer's law? Why should that absorbance or below that number be maintained? This is 1.040. I think we're going to be close enough to 1 for that to be okay. Now, since I'm still not absolutely sure about my other one, we're going to move into our unknown. We're just going to do several rinses. Three times is the magic number for any analytical process that you're doing. Rinse this 3 times. Pop it in. And let's get a reading. At 510. Same nanometers for everything. Same wavelength. This is 0.147. We'll still need to rinse several times. Oh wow, the top of that just broke. Did you see that? Wild. Okay, that must have seen one too many days of acid because it was degraded. 3 rinses. We will fill with this one. Pop it in. Read it. And we won't use our top anymore here, I guess. Well, we can set it on lightly. Don't want it to get stuck in my volumetric flask, though. Have had that happen. That's not fun.
Probably a problem with the glass stoppers, though.
0.142. That does not sound good. Yeah, they broke. They got the ring. Dr. Son was over here. Three rinses. Fill. Wipe this off. Pop it in. And let's read that. Then we'll go back and do our first point for our standard curve, since it has definitely been 10 minutes now. This is 0.145. We will have to do several rinses with this one now because we have gone out of our sequence. Trying to put the stopper on the cuvette. Not a good move, huh? Does not fit. That's like a round something in a square something. Doesn't fit very well. You know, kind of like doing online analytical labs. We're doing what we can for you. At 510, we have 0.020. All right. Now, that concludes this experiment other than cleanup, which I'm sure you do not need to see me do. So you will need to take those values. I will put these on canvas for this lab. You'll need to take these values and you will need to make your standard curve. You'll need to talk about why you had to make a standard curve. And then what you're going to do is you're going to find the concentration of iron in your unknown using that standard curve. Then you're going to do your statistical analyses on that, so you'll be able to do an average, standard deviation, and percent RSD. All right.